everyone. Welcome and thank you for joining us today. Our speaker today is Dr. Sina Mossahebi. He is a medical physicist and associate professor at the University of Maryland. Dr. Mossahebi will present breath hold radiotherapy, workflow, and benefits. If you have any questions, feel free to write them in the chat and we will address them at the end of the presentation. Dr. Mossahebi, thank you for being here with us today. The floor is yours.
Thanks for the introduction. Good afternoon, good morning, good evening, everyone. I'm going to talk about breath hold radiotherapy and then focusing on the workflow and its benefit. This is my disclosure. About our center, Maryland Proton Treatment Center is part of the University of Maryland. We have variant ProBeam. We have 5 rooms, 4 gantries and 1 fixed beam. We started treating patients on February 2016, and currently we use 4 rooms for patient treatment. And so far we treated more than 5,000 patients. At our center, we have Siemens dual energy CT scanner and a Siemens MRI scanner. And in one of the rooms, we have a surface guided radiation therapy or surface guided imaging, Vision RT. And for special treatment, we have a SDX breath hold system from DYN'R. We started using the system on March 2018, and so far we treated more than 250 patients. And also we have a deep thermal therapy, and that one we started on October 2018, and we used that for the pelvic treatment, and we treated more than 100 patients. This is the outline of my talk. Initially, I start with the introduction, talking about the motion management, and then focus on the SDX system and how we can set up in the room, and how we do the QA on the SDX system. And then the second part is going to be the patient preparation and training, initial simulation, and then treatments, which focus more on the for the radiation therapist. And the other part is about the treatment planning, talking about the contouring and what we need to consider when we do the contouring, and then beam selection, and then some plan parameters that we can improve the plan or the quality of the delivery. And the last part is about the evaluation of the breath hold plan. So I'm looking at the breath hold versus non-breath hold, and look at the target volume and the dose to OARs, and also look at the reproducibility of the breath hold plans. Typically for motion management, we use external breathing metrics, which can give us a predict the tumor motion. And by using that one, we can reduce the respiratory motion uncertainty, and we make our dose clot smaller. Then we can finally spare normal tissue. One of the methods is breath hold technique, which mitigate motion of the target, which then we have a minimize target margin and spare normal tissue. There are different methods in general. One is a non-spirometric, which use an external surrogate. And the other one is the spirometric, which is using the internal volumetric airflow. So the non-spirometric is like a surface-guided imaging, like Vision RT identify, and we can use RPM or RGSC from Varian. In the spirometric, we have a active radiant coordinated or ABC system, and also SDX from DYN'R. Looking at each one and the advantages and the disadvantages of them. So the non-spirometry, clinically they're feasible. We can use them to reduce the tumor motion or margins, and do the breath hold planning on that. They give you audio-visual feedback, and which helps you to improve the reproducibility of the treatment delivery. You can have a gated treatment delivery, and it gives you a surrogate of the internal respiratory motion. And it's also as comfortable for the patient. So patient doesn't feel anything, extensive on the chest wall, and is more comfortable. The disadvantage is this is an external surrogate. It doesn't give you much information about the internal volume. And also it gives you a 1D or 2D information, depends on if you use RPM, RGC, or Vision RT. And it's some of the systems, they don't have the gating modules, so you can't have the gated treatment. And some systems, they don't give you audio-visual feedback, so then it's kind of a problem for the reproducibility. For some treatment like Proton, when we use the SGRT system, there's a kind of clearance issue of the source to detector, and then the snot can block the camera, so that you can't get a good signal for that one. And also it's a position dependent. The other issue is they are kind of like, room specific. So if you have the SGRT system in a room, you can't move it to another room. So you have to have another system in another room if your system goes down. So that can be a challenge for the treatment. In the spirometry system, they are still like same as non-spirometric, that are clinically feasible. You can have an audiovisual feedback, and you can have a gated treatment, and it's an accurate surrogate of the internal motion and easily portable. So you can just move the system from one room to the other room. The disadvantage of the spirometry system is the signal drift, and so that's why we have a QA for that. And it's kind of uncomfortable for the patient because patient is using mouthpiece and nose clips, so it's not really comfortable for the patient. And some systems, they don't have the gated module, so then they can have a gated treatment. And still is only a surrogate. It's not actually tumor tracking. And at our system, at the MPTC, we have SDX System from DYN'R as a voluntary breath hold technique. So it has different components. It has an airflow tube, and then we have the filter, and then connected to the mouthpiece. And then we have a nose clip that I'm going to talk about that, and the video glasses that patient can see the monitor or breathing pattern. And all these three, the filter, mouthpiece, and nose clip, they're single use. So we use it for each treatment. And unless we have the patient for a quality assurance CT, we may reuse them, but otherwise it's a single use component. And we use SDX for the treatment of the lung, pancreas, liver, esophagus, abdomen, and thorax. So what we have as a mouthpiece that the patient kind of, it's like a snorkel. Patient has it in the mouth and breathe through this mouthpiece. It has to be tight and sealed. And then we have a nose clip to kind of close the nose, and the breathing should go only through the mouth. And then we have a video glass, that the old video glass from SDX and the new one, which gives you adjustable focus, and also the handle is more flexible and gives you better image quality. So patient can see through this video glass the breathing motion and breathing pattern, and also like the breath hold level, and then it makes the treatment more reproducible. There are different components. So there are one set of components from SDX. We have SDX system, computer, and gating module. And then treatment component is the treatment machine gating module, and treatment console, and treatment machine nozzle. So in the treatment room, it doesn't matter if it's proton or photon. So you have the system inside the room with the patient, and everything is connected to the patient. And then the SDX system is connected through Ethernet cable to a SDX computer outside the room in the control room. And that one is connected to the SDX gating module, which is connected to the treatment machine gating module. And then that one controls the beam delivery. For quality assurance, one disadvantage of the spirometry system is the signal drift. So what we need to do, we need to do the QA. So there's a daily QA that you have to do when you use the SDX system, which checks the calibration of the system. So ensure that there's no change in the signal drift, and then there's no signal drift, and there's no change in the calibration parameters. To do that, you need to wait about 5 minutes for the warm up. So then the calibration check stabilization is kind of like, ready. And then you connect the system to the cylinder. Is a 3-liter cylinder. and you start kind of pumping the cylinder, and then create this like cycles of like a in and out flow. So the system at the end, because the volume is 3 liter, based on this 3 liter and 2% tolerance, it tells you if the calibration is good, is passing the QA, or if not, then you need to recalibrate the system. For recalibration, one thing is because the system has to be really stabilized, it needs 20 minutes wait time. So you need to wait 20 minutes, and then you can go to the calibration tab and start the calibration. So in that one, basically the system doesn't know anything about the volume. So on the y-axis, you don't see any volume. So what you do is like you just do the kind of like 4 cycles of the pumping, and then at the end, you tell the system the volume is 3 liters, and based on that, it gives you the calibration parameters, and it forces you to go and do the calibration check. So then you have to do the calibration check, and if it passes, then you're good to go. Now, I want to talk about patient preparation, training, and initial simulation. So this is more focused on the radiotherapy side. So one is like the first part is you have to enter the patient in the system and the SDX software. So you enter the last name, first name, and patient information. You have to verify the patient information. And then you go to the next step, which is the preparation. So basically, you want to teach the patient how to breathe using the system. And then also you want to establish a DIBH, deep inspiration breath hold, and the breath hold levels. So to do this, we start with asking patient do like 3 to 5 normal breathing, and then that goes to the deep inspiration breath hold. Then we find the DIBH level, and you have the options to pick one of them or do the average, and they just type the number there, and then that's your DIBH level. The next step is you'd reduce that level to 75% to 85%, depends like what you're comfortable with that, because in that level, it's not the deep inspiration, so patient is more comfortable and is more reproducible. So the default value in our system is 75%. So by clicking that percent sign, it gives you the 75% of DIBH as the breath hold level. And then you do some practice to make sure that's reproducible. The next step is the CT simulation. So in this part, you ask patient to have the goggle so the patient can see the breathing pattern. So you go to the imaging section, and then on the software view or like a therapy or the control room view, you can see this graph on the left. On the right side, you can see the goggle view, which is what patient sees. So then you ask patient to do the same thing, normal breathing for a couple of cycles. And then when you see the green square, you click on that one. So it shows up the screen bar in the software view, or the green kind of circle on the right side for the patient. And you ask patient to have the moon inside that circle. So as soon as patient gets to that point, it means patient is on the breath hold level. So they count on the start, and then you can start the imaging. So you start your CT scan at that point. And if patient goes out of that level, you stop the scan, because the system is not connected to the imaging gating module. So it's not stopping the scanner. Then when you're done with this, you do this for probably 2-3 cycles, like 3 scans, to make sure this is reproducible. And also you can use all those scans to counter the target, and you can call it the ITV of the breath hold. So in general, in the imaging part, the CT is happening at the breath hold level, and if a patient goes out of that level, you stop it immediately, and this has to be manual. And we typically ask the patient to practice before this, and because the more the patient practice, they can they're more comfortable and they can hold their breath longer. And we start the scanning from the top of the head, kind of like from the goggle side, because we want to capture SDX system up to the point that the physician requests. And we also do the extended field of view. So in our center, we do 500 or 600 for our clinical field of view. We can do like more than 600 field of view. And that one is to capture more of the system. And then you can kind of better estimate the air gap or SSD if you're using the system in the treatment and make sure there's no collision. Also, we have a backup plan as a free breathing or the 4D CT scan. So we want to use this, for different reasons. One is like if the one of the rooms is down or patient cannot do the breath hold anymore, then we want to move to the free breathing without interruption of the treatment. The next one is the treatment planning, which I'm going to talk in the next section, but there's like we do SDX plan and normal 4D CT plan, and then we do the comparison, then the physician does the evaluation of the plan and select which plan they want to do for the treatment. And then after that, we send it for the patient QA. And for the treatment day, so we do IGRT, we do KV and CBCT. The CBCT at the pro beam for the small field of view takes about 30 to 35 seconds. And after that, we do the treatment using the gating module. In the treatment room, first you set up the SDX on the couch, and then with the immobilization device, you make sure that the wires are not on the way or in the beam path or like kind of like, in the gantry that, cause the collision. And then you put the SDX system on the couch, and then you have the patient on the couch and make sure everything is connected, and put the mouthpiece and nose clip and the goggle for the patient, and make sure the patient can see the window or the SDX software. Then we start the IGRT. We do KV and CBCT in ProBeam. The full fan or the small field of view takes about 30 seconds. And LENAC is almost the same, as about 35 seconds. And if even you do the short arc CBCT, that's which is like 100 to 20 to 150 degree, that one takes about 20 to 25 seconds. So you need to make sure the patient can hold the breath during that 20 or 25 seconds. If not, you can resume the scan. So, and ask patient to go to breath hold again, and then resume the scan, and then kind of like, get the final CBCT at the end. So the IGRT part is manual. If patient goes out of the breath hold level, you have to stop it yourself. And then for the treatment is automatic. So it's connected to the gating module. So as soon as patient goes out of the green bar or that circle, stops the beam. And what we also do, we do the weekly QA-CT for evaluation, make sure there's no change in the anatomy, and look at the tumor response, and make sure the plan is valid for the whole course of the treatment. Some notes about the setup or scanning. So one is when you do the breast setup. So typically we ask patient to have the chin turned to the contralateral side, and then same as the SDX system. The other part is when you have the neck and mediastinum patients. So at our Proton Center, we use boss frame with a mask. And then sometimes we want to also have the motion management. So we use SDX. In that case, because the boss frame, there's no place to put the SDX system, we design a flat plate that's connected to the base of the CT table. Then we can put the SDX on top of that. Similarly, for the treatment room, again, because sometimes the couch is higher than the SDX level on the cart, so we have another platform that's on top of the couch, then put the SDX system on that, and then connect those to the patient for the treatment. For workflow, in general, so we, after the consultation, and if physician want to do the breath hold, we send the patient for the SDX preparation and patient training, and we do evaluation if the patient is good for the breath hold treatment. If it's good, then we do the both non-breath hold and breath hold simulation, and we do planning on both of them, and then the physician does the evaluation of the plans. And if he decides to have a treatment, with the breath hold, we do the patient Q on that one. And if they want to do the non-breath hold, then we do the patient Q on the non-breath hold plan. But we want to have a backup plan anyway, so we do both of the QAs, and then we have both of them ready for the treatment. At our center, so far we had 296 patients underwent for the CT simulation for using SDX, and we treated 260 of them with the SDX system. And most of them were liver and lung and mediastinum for the treatment side. About the fractionation, we have most of them are like a hypofractionation, and like we had like about 31% 2 to 4 gray, and then some SPRT case and a couple of grade cases. In summary of the first part, so we can use this system for any moving tumor due to breathing. And then we ask patient to the breath hold practice and make sure the patient can hold the breath for at least 30 seconds for the CBCT. Then it's easier if you have a smaller target and less beam, because then for patient it's easier to do the less breath hold. And we, as I said, like it's good to ask patient to do the practice before coming for the initial simulation and also treatment. We use KV and CBCT for IGRT, and then we do weekly QA-CT for plan evaluation and make sure there's no change in outcome. In the second part, I'm going to focus on the treatment planning. So the first one is contouring. So for contouring, when you do the external or body contouring, you need to include the SDX system and its component in the external contour. So that helps you to accurately calculate the air gap or SSD and also avoid the collision. The other part is the beam selection. So when we have the SDX system on the couch, so you need to consider the gantry size. It's not only about the field size. So you need to, for the pro beam system, the gantry is much bigger than the actual field size. So you need to consider that like there's no collision. And especially when you use range shifter and you have the snot closer to the patient. So it's better to do the collision test before the actual treatment. And also, it's good to use the extended field of view, and then you can see more of the SDX system, and then you can use that field of view or scan to generate the external contour, then accurately calculate the SSD and air gap for the planning. For optimization, it's similar to the normal treatment planning. There's not much difference between the conventional or breath hold planning and the optimization parameters. We use Monte Carlo for proton planning. It's better for the dose calculation. There are some things that you need to consider when you do the plan. One is that you have to activate the gating part. So that one is like, basically you tell the system this is a gated plan and it's looking for the gating signal. So in Eclipse, there's a box and the plan parameters or plan properties that you use gated, so it has to be checked. Or if you're using Ray Station, you can go to the motion synchronization and check that one. And you can define if you want to have the gating with the external marker or the spirometer, or like you can just rename that to SDX and then use that one for the actual planning. The next one is the how we can improve the delivery. So if you have the faster delivery, so then there's less kind of problem, problem for the patient to do the breath hold, because it's faster beam delivery. So if you can use the higher dose rate for the photon, like if your routine clinical is 400 MU per minute, if you can go to 600 or higher, that it makes the delivery faster and it's easier for patient. Also, you can limit number of the arcs or like beams that you're using. So it's better to not have more than like 2-3 beams or arcs, then it's easier for the patient. And the goal is to minimize the time of the delivery and makes this more comfortable for the patient to do the breath hold every day. In Proton, is the same thing. So there's no kind of like parameter or dose rate change. So what we can, you do is like you change the minimum MU per spot in each energy layer. So if you go from 1.1 to 1.5 or 3 or 5, that helps you kind of like improve the dose rate or like a treatment delivery. So we did the study. We generated the plan with the 1.1 MU as a minimum MU and 2 and 3. And we saw that there's no change in the plan quality. And that by doing that, you can decrease the delivery by about 20 seconds for each field. So that helps, you know, for the treatment, and the patient is more comfortable to do this every day. The other part is for breast treatment, and especially for photon. It's important because, you know, if you're using the tangent beam or VMAT, and you know, for the free breathing, the heart is getting close to the chest wall. So by doing breath hold, you kind of give the separation between heart and chest wall, and you can spare heart better. So this picture shows that, like, you know, on the left side, this is the free breathing, and you see, like, you know, you know, you have a significant dose to the heart, versus if you do the breath hold, you can move the heart away from the chest wall and spare normal tissue. This is more for photon. For proton, you can do the same thing, but the problem is the delivery is kind of slower compared to the photon, and it's kind of hard for the patient to do the breath hold for a longer time. There's some challenges if you use SDX system. One is like because, you know, this increase the treatment time is not really comfortable for patients. So you have to kind of like make sure that patient can do this for the whole treatment course, and then you do the evaluation of with the QA-CT, make sure there's no change in the actual treatment. And also, if you use range shifter, it's kind of like makes it more challenging, because now you have a limited kind of like beams, you know, or like angles that you can use if there's SDX system kind of on the way of the range shifter, and because you want to minimize the air gap and then make the plan more conformal. To conclude for this section, the treatment planning, so you have to include the SDX components in the treatment planning CT and the external contour, and it's better to use the extended field of view to do the contouring for that one. And if you're using the proton machine and you have the snout, you need to make sure the gantry size is not same as the field size, so you have to make sure there's no collision. And in the planning, in the plan properties, you need to make sure that the motion synchronization or gated is on, and to reduce or make the plan deliveries more efficient, it's better to reduce the number of beams, and also use a higher dose rate, and both proton and photon. And also, like, you know, you need to do the QA-CT to make sure that there's no change in the plan, and then do the evaluation of that one. And the last part is look at the breath hold plan versus non-breath hold, and kind of look at what's the benefit of the breath hold system. So we said that breath hold can minimize target margin and improve the normal tissue sparing. So we want to evaluate that one. So initially, when we started, we had one SDX system in one room, so we were not comfortable to have only one system in one room. So we decided to have a backup plan for just like a 4D backup plan, in case, like, you know, patient cannot do it, or the system doesn't work, or the room is down. And then later, because of COVID, we again decided to keep doing this and have that backup plan. If the patient comes with a COVID symptom, then we can use the backup plan and not use the SDX system for the treatment. So because we have like both plans for, you know, for the patient, so we did a study. We looked at the 77 patients, and for different treatment sites, mainly liver and mediastinum and lung. And we have the breath hold, clinical acceptable breath hold, and the 4D backup plan. And we look at the DVH parameters and look at the target volume, and also the OR doses. So this is the example. Like on the left side was the breath hold image, and on the right side is a non-breath hold or average image. So we have a GTV contour and CTV. On the right side, you have the CTV or ITV, which is kind of like, you consider all the phase of breathing phases. So as you can see, the volume, the target volume is larger if you use the non-breath hold versus the breath hold. So because of that, so then you have a bigger dose cut for the non-breath hold, and then so you have the same coverage on the GTV or like the target, but you can see like more sparing on the breath hold versus the non-breath hold. So the solid line is the SDX or breath hold plan, and the dashed or dotted line is the average plan. So we look at the data, so of the CTV, the initial or the boost plan. So overall, it's about 30% reduction in the target volume. And when we look at the ratio of the target volume, where the breath hold versus non-breath hold, so the more motion we have, the more reduction you have in the volume. So if you look at the ratio, so if there's not much motion, it's like maybe if it's not comfortable for the patient, you don't need to do the breath hold. But if you have a significant motion, it's better to do breath hold and reduce the target size and the spare normal tissue. Then we look at the OIR doses, the max OIR dose for different organs, and overall we saw about like a 15 to 35% reduction in the dose to the normal tissue. And also lung V20 and liver mean dose, it's about 25% reduction. And similarly for the mean dose for the other organs, it's about like 20 to 30% reduction in the dose using the breath hold system versus not breath hold. And the last part is look at the reproducibility of the system. So we said we are using breath hold, we can minimize the target margin. Now the question is this plan reproducible during the course of the treatment? So we, at our center, we do weekly or weekly QACT to look at the tumor response and change in anatomy and see if we need to do the replan for the rest of the treatment course. So what we did, we looked at the 30 patients and the 62 QACTs. And for all these plans, we use 5mm robust evaluation and the optimization for different treatment sites, and we'll look at the reproducibility of the plan based on the QACT evaluation. So we'll look at the target coverage, and if we have more than 5%, we change in the V95, we consider replan, or if there's a significant change in the OIR dose or increase in OIR dose, we do the replan. So then we look at the deviation parameters and look at the percent difference of the target coverage and also the absolute dose change in the OIR. So this on the left side is the volume. So we didn't see significant change in the volume of the target, CTV1 and CTV2. And also we look at the target coverage, V95, D95, and mean dose. They're less than like a 5% in general in the coverage. And max and minimum dose of the OIR, the target is kind of higher because, we are looking at the pixel value instead of like actual the volume. So you see kind of a more change in the minimum dose if you look at the QACT versus initial plan. Also, we look at the OIR dose, so we didn't see significant change in the mean dose, max dose, and the lung and liver value, the dosimetric parameters. Based on all these those 30 patients and 62 QAs, we saw only 4 replans, and mainly because of the change in the target and OIR, because of the change in the anatomy that we saw the change in the target coverage and the OIR dose. In summary, using breath hold, you can significantly reduce the target volume by 20 to 25%. And then you can spread the normal tissue. And we saw that there's a kind of significant reduction in the dose to the normal tissue, either mean dose or max dose. And in the absence of the change in anatomy, so we saw that the plan is reproducible and it gives us a good coverage and no significant change in the OIR dose. And using the 5-minute robust evaluation. It gives us a reproducible plan. Similarly, if you have a photon, you can use PTV and a kind of acceptable margin to have a robust plan. Thank you.
Thank you, Sina. Thank you for a great presentation. We actually have a lot of questions in the chat, so I'm going to read some of those and let you answer. All right, so the first question was, can we elaborate more on the connection between breath hold at SIM and at treatment? Is this based on the volume of air in the lung?
So yes, it's based on the flow that going through the system. Is not actually measuring the lung volume. So it's measuring the tidal volume or breathing volume. So how much flow goes in and out in the system.
Okay, thank you, Sina. We have another question from one of our clients that says, we have not transitioned to the curve to the moon view for patient goggles. Do you see any clear benefit to the moon view over the curve view?
I feel it's easier for the patient to understand because they look at the one dimension as just like you have a moon going to the circle. It's easier, especially if you have old patients. Then, versus the curve that has a time component also, it's kind of maybe it's a bit more confusing. So we feel it's easier for the patient to understand that part.
That was the feedback from the therapist team?
Yeah.
Okay, thank you. For lung treatment, in your experience, how many patients were able to hold the breath, and in how many patients you have to go back and plan again?
Unfortunately, I don't have the data for that one, but I don't have it here. But for our treatment, I believe we had 296 patients kind of referred for SDX simulation, and out of those, we treated 260 patients. So basically, that ratio is it's maybe about 90% or 85% they could do this. And there were a few patients that they couldn't do the breath hold treatment during the course of treatment. There were maybe 1 or 2 patients that they couldn't do it, and we decided to go to our backup 40 plan.
Mm-hmm.
But in the initial simulation and the kind of training, it's kind of easy to find out which patient is good for this or a good candidate for breath hold versus because if you have a patient without teeth, it's not a good candidate. Or if the patient is blind, you can't do this. So these are some stuff that you can easily find out in the training phase or actual initial simulation.
Thank you. We have a very technical question. What is the minimum air gap possible with SDX system?
So if you have the air gap, like a SDX, the whole component in the external, so we can have up to you can go less than 10 cm, as long as there's no collisions, as long as you consider SDX as an external contour, there shouldn't be a problem. But you need to consider that it's not only the beam or the nozzle. You have the the gantry is kind of you have other components, imaging components. There shouldn't be any problem with that one as well. So typically we use 12 cm as minimum air gap, but if you want to have more conformal kind of plan, and which, for example, for us, for great cases, we can go to 6 cm, make sure that there's no collision. We use 6 cm before, so.
Mm-hmm. We have another question that asks, if patient releases the breath hold, then it will not turn off the beam automatically. Therapist will have to turn off the beam manually. Am I right?
No, depends on your system. If you have the gating module, the system itself has to have a gating module, and you have to have a gating module from SDX. You don't, if you have both of them and connected, you don't need to worry. So it's kind of as soon as patient goes out, out of that breath hold level, stops the beam. So in our practice, what we do is when, because in the Proton, you request beam, you receive the beam, and you're waiting. So we press beam on without patient going to the breath hold level. Then as soon as patient do the normal breathing and goes to the breath hold level, beam starts, and as soon as comes out of that breath hold level, stops the beam. So therapy, they don't do any manual beam interruption for the at our system. So as long as you have gating system, it shouldn't be a problem.
And the SDX can interface with a lot of different machines. So if you have any question for a specific machine, just send us an email and we'll make sure to answer you. We have somebody that is asking, what are the criteria used to evaluate if the patient is a candidate for breath hold at Maryland?
So at Maryland, one criteria is like we want to make sure patient understand the system and do the breath hold. The other one is make sure patient can hold the breath for kind of like enough time. So at our system, we prefer to have like 30 seconds at the minimum, because our CBCT takes about 30-35 seconds. So if patient can hold it 30 seconds, so that's good enough for doing the imaging. The treatment is not a problem because, beam interrupts and then you can resume. For imaging, you can do the same thing. You can resume, but sometimes after, you have the, imaging interruption or you stop the imaging, it may give you a fault that resets everything. So you have to repeat the whole imaging from the beginning. So in LINAC, this is less issue. So, you can have 15-20 seconds breath hold. That's enough because you can easily resume, but it's better to have 30 seconds at a minimum because it's more efficient. And the other part is when we do the breath hold scanning. So if you do a couple of them during the initial simulation and you see okay, patient can do it and there's no change in the scan much, based on the breath hold. So you feel like you're comfortable to do breath hold. So that's one of the criteria for us.
Okay. Another question is, can SDX be integrated with VisionRT or other SGRT system? Suppose only SDX is used in planning and both SDX and SGRT are used during implementation. Is that sort of integration possible?
You can have both of them in the room. So you can have SDX system, you can have a SGRT system. You can monitor the surface with SGRT. You can check the breathing or volume with the SDX, but I don't think you can use both of them for beam gating. So you need to use one of them for beam gating. So you can use both of them and then do evaluation, but for gating or actual delivery, you can only use one of them.
Somebody asked actually a follow-up question on that. They asked for which sites, is it site specific?
Treatment site?
Yes.
As long as that it's you have motion during because of the breathing, so you can use either one. But VisionRT or Identify, those systems, they're not just only for kind of breathing, so they can use this for SRS cases and patient monitoring, or so those are different. So they're kind of gives you the surface information, but they're not really tell you about the breathing motion or volume inside. So, but they have other kind of purposes, but SDX is only for breathing.
Yeah, there's another question actually that is also related to that. The doctor asked, since your site has both VisionRT and SDX, which system are you and your patient happier with?
So we don't use both of them for the same purpose. So we don't use Vision RT for breath hold treatment because one is we have it only in one room. So if, that room is down, we can't use it. So we don't have it in the other rooms. And the other one is because of the camera is getting blocked with the nozzle, especially if you use range shifter and then you have the snot closer to the patient. So it's kind of blocked the camera and then you don't get enough information. So we can't trust it, especially if you do the proton treatment. So we use SDX for breath hold, but we use Vision RT for breast patient setup and treatment.
Thank you. Another question is, in your institute, the MD decide if the patient is breath hold or free breathing based on 40 CT. Besides breath hold, do you also do gated treatment, which includes several breathing phases for patients who cannot hold their breath but have large motion in 40 CT?
The second one, no, we don't do it. The first one, MD, in the initial consultation, they kind of, if they feel okay, this is like because of the treatment side and motion, and then if they feel okay, this patient can do it. If you have a really old patient or someone cannot do breath hold at the from the just initial consultation, so they don't refer it. But usually they ask therapists because you have to schedule kind of training session for them, which takes probably 30 to 45 minutes. So then after that, after the scan, they may do 40 at initial and then SDX later. And then if they see lots of motion, even with compression belt, then they decide to go with the breath hold.
Okay. How does the expenses change moving to the SDX technique from a respiratory gating technique? And by what factor this technique improves the dosimetric outcomes compared to conventional gating for OAR and the target?
So expenses and the cost. Yeah, so about the OAR sparing, so if you use breath hold in general, you can spare normal tissue. So you have less motion when you create your ITV. If you use ITV based on breath hold versus free breathing, definitely it's going to be smaller with the breath hold. So if you have a smaller target, you can spare normal tissue better. So that's a kind of benefit of breath hold in general.
Okay.
And what we saw based on the just evaluation of 77 patients, we saw the volume reduction is on average about 25%, and that also same thing for the normal tissue dose.
Okay. Do you experience patient where the anatomy, for example, diaphragm level or lung volume, is different between SIM and treatment at the same SDX breath hold level?
Yeah, we have seen in a couple of cases.
Yeah.
And that's that can be because of different reasons, the way patient breathe, or maybe initial simulation patient was nervous versus treatment or some other factors. So and we have seen this before, and it probably maybe few patients, not a lot, maybe 5 patients that we have seen this, and we decided to change the breath hold level. And there's no way in the system you go back and change the breath hold level. So you have to kind of fakely create a new patient and type that number that you feel like, okay, if patient with the breath hold level was 75% of the IBH before, and now you feel okay, patient has to kind of go breathe more, then you can increase it to 80% or 85%, and just do kind of a quick CT, make sure that it's the same. So you can do that way. And then we have done this as long as the imaging matching, so you can change this. We have seen this in a couple of patients, so it's not kind of uncommon.
Okay. How do you deal with patients who can't adequately create a seal with the mouthpiece? Basically, how do you deal with any air leak?
We don't do breath hold. We, if patient cannot do the complete breath hold kind of procedure, or do the breath hold perfectly, we don't do it. So we go with average because it's safer.
I think we have also great webinars from therapists that explain how they can deal with that situation as well. You can find that on a YouTube channel. I will put it in the chat in the end. We have another question. Could you elaborate on mapping the target volumes between the breath hold scan and 4D CT? Any uncertainty associated with this?
Mapping the target volume. So the part that I presented, look at the CTV volume. So the CTV from breath hold, you can have the CTV based on the multiple breath hold scan. So you can, during the CT simulation, you can scan the patient a couple of times, and on each, scan, physician can do the contouring, and then you create the ITV of breath hold or CTV of breath hold. And for 4D, you can use different phases or MIP to create the ITV, and then you can just do the comparison between the volume of those.
Okay. Do you have any concern with the timing, latency, and lag in the system? The delay between coming out of the desired level to beam off? I believe you measured that.
So the delay beam off for the SDX system is less than 100 milliseconds. So we are not concerned about that one much, because I believe it's less than, it's about 35 or 50 milliseconds. So it's same as most of the it's kind of coming from the gating module. It's not about the system. As soon as the signal transfer to the system, your treatment delivery system, stops the beam. So that's about less than 50 milliseconds. So we are not concerned about that one. And then what we did when we did the commissioning, we did multiple plans with the with SDX system, and we create a multiple interruption with the in the signal. So it's kind of we do one delivery without any beam interruption and multiple with beam interruptions, and then we deliver it to the detector, and then did the absolute and also profile dose measurement, and all of them were kind of within all the profile with 1%, the criteria of 1% and 1 millimeter passing more than 98%, and absolute dose, all of them within 1% of the delivery.
Okay. We have an interesting question. For which treatment site do you find breath hold being the most useful?
So for liver, lung, if patient can do the breath hold, pancreas, these are the main sites that we use a lot. And liver, it's easier compared to lung because usually if you have the lung patient, they may have problem with the breath hold, but we use these three sites are the main sites that we use.
Okay. We still have a lot of questions, and I'm not sure we'll be able to answer everyone today. So, Sina, if you want also to maybe drop your email address in the chat, if people want to contact you. We do have one more question. If the simulator is not synchronous mode compatible and the treatment machine is, can sim be done in manual mode and treatment be delivered in synchrony mode for the same patient?
Yeah, so we don't have the system, SDX system is not at our center, it's not connected to our CT simulation or IGRT system. So you have to manually interrupt the beam. It doesn't matter, because that you do the imaging. The part that, like, you tell the system this is gated is in the planning phase. So you tell the system this is like gated plan, and that one, if the system, your delivery system is capable of doing that, then you can use it for the gating.
A follow-up question for the treatment site. Do you use DIBH for breast, with nodal treatment, including the IM nodes?
At our Proton Center, we don't, because we don't use breath hold for breast in the Proton Center, because there's a benefit. The main benefit is you can move the heart far from the chest wall and breast. But the problem is usually the treatment delivery takes more than like minute or so, like 2 minutes, 3 minutes, depends on the size. So we are kind of like feel like you're more comfortable not using breath hold and just using the free breathing for the breast treatment. Especially for proton, we use on-fast beam, and those are kind of like they're less kind of affected by motion, because you have the beam in the direction of the motion, so it's not really significant.
Have you tried using supplemental oxygen to extend the breath hold?
No, we have not.
I know there are some other sites that actually tried. So if you have any question about the supplemental oxygen, you can email us, and I'm going to write my email address in the chat. Okay, I think that we answered a lot of questions today. Thank you, Sina.
Sure. Thanks, everyone.
We have a few more minutes if there's more questions. Otherwise, I will write my email address in the chat right here, and then I'm also going to copy paste the link to our website. If you want to see the recording of this webinar, the recordings of the previous webinar as well, and if you want to ask us any questions. All right, everyone. Thank you very much for being with us today. Have a great day, everyone. Bye.